Hey everyone, so here we have a question from the radioactivity chapter, dual nature, nuclear physics, okay? So it's from nuclear physics. It's from JEE Advanced 2022, paper 1. Okay, so this question is really interesting, okay, like a serious question. It goes like this: the binding energy of nucleons in the nucleus can be affected by pairwise Coulomb repulsion. That means that the nucleons in the nucleus, they have repulsion between them, electrostatic, Coulomb or electrostatic are the same thing. Assume that all the nucleons are uniformly distributed inside the nucleus. Let the binding energy of a proton be this, and the binding energy of a neutron be this. Okay. Now, first of all, let us understand one thing. In a nucleus, there are equal number of protons and equal number of neutrons, right? So proton will also be repelled by each other, because the positive repulsion, and neutrons won't be repelled by anything because they don't have any charge. So that means removing a proton is simpler than removing a neutron. That implies that binding energy of a proton is less than binding energy of a neutron. Okay, so that implies option C is wrong. It says that it's positive, whereas it's actually negative. Fine. Now, see, this is your nucleus. Okay, there are positive electrons everywhere. Okay, it has some self energy. This K is Z square by 2R, self energy of all the neutrons, all of the nucleus for that matter. This will be that. Okay, now if we remove, we have to remove one proton. It will be easier to remove a proton than a neutron. So if we remove a proton, okay, then the self energy becomes K Z minus 1 P square upon 2R. Okay, this is just the energy difference with the repulsions. Okay, and this will come out to be then Kz minus 1 whole square, so Kz minus 1 square only, E square by 2R minus Kz square E square by 2R. So this will be equal to K square by 2R common, Z minus 1 whole square minus Z square, so it's A square minus B square, Z minus 1 plus Z into Z minus 1 minus Z. Okay, this gets cancelled, and what we get is 2Z minus 1 K square by 2. Okay, we'll take the mod here. So this implies even option 1 is wrong. Okay, and if you look at option B, it says that EBP minus EBN. See, this is EBN. If we remove a neutron, okay, this guy will be EBN, because if we remove a neutron, this will be the energy. Okay, but if we remove a proton, this will be the energy. So the binding energy difference will be the difference of this two, and that's why we did this. I hope you understand. Now EBP minus EBN is proportional to A to the power, so A is A to the power. You need to understand one thing: R is directly proportional to the atomic mass to the power. Okay, so it is inversely proportional to R. So yeah, option B is correct. Now let's check at this guy. Now positron means what? A proton converted to a neutron. So proton becomes a neutron plus P plus, This is positron. That means now number of protons is decreased in the nucleus. Now if it is decreased, then the ease of removing the proton would decrease. Now if ease of removing the proton is decreased, that implies they are binded together more effectively. If it's tough to remove, it's